Welcome back. Today is a special edition. We actually continue with linear equations and explore the gradient. Let us ask a subject matter expert. Mr. Einstein, welcome to our studio. Mr. Einstein, let me just ask you the same question we asked all these different people. What is a gradient?
I've been asked to talk about a line's gradient. You know, like inflation is always on the rise, and I'm always on the run from my creditors. My financials are over. So put come around, you get rise over run. And that is the simplest way to
Okay,
remember.
so
You
can
want
you tell
another
us another
format?
definition?
Okay, you really get me to pick my old brain. You can't even rest when you're dead. Anyway, it is the tangent. So if the angle between the y and the x is known, then from that angle you get the tangent, which is opposite over adjacent, or over a, you get the gradient. Is that good enough for you? Or you want still more?
Alright, now, but hang on a second. If you already know the angle, you only need to say tangent of that angle and you get the answer. Why do you still need the opposite over adjacent values?
Ah, it's good to see that you are awake. Yes, indeed. If you know the angle, just in the calculator. See, nowadays you are spoiled. That did not exist in my days. Anyway, in the calculator, you put tangent of that angle and you get the answer, and that would be your gradient. Now, if you don't have the angle, but you know the opposite and adjacent sides, which just happen to be rise over run. You remember rise? Yeah, I'm running. Oh, yeah, rise over run. Opposite over adjacent. Also, that would be the formula for gradient. Now, let me rest.
Okay. Now, Mr. Ashman, let me just bother you for last time. Is there still yet another definition?
Okay, alright, there is another format. Yes, we covered when you know the angle, you covered when you know the sides. Now, the third type is if you know 2 points on that line. So if one point has coordinates x1 and y1, and the second point has coordinates of x2 and y2, then the gradient would be y2 minus y1 over x2 minus x1, which also coincides with the rise over run and the opposite over adjacent. Okay, satisfied? Now let me be, and good night.
Thank you very much, Mr. Einstein. That's all. You can rest now in peace or pieces. Anyway, uh, let's go back. There is still one more definition. The gradient is actually the slope. So if you think about the side of a ramp or a mountain, then how steep it is actually the gradient. Okay, we come to the finish. Till we see you again, I bid you farewell.